be with you like a forever chemical. I wanna be with you like a forever chemical.
Hi, I'm Dr. Craig Butt, and I'm a staff application scientist at SCIEX. Welcome to another episode of Dr. Craig's PFAS Fireside Chats, where we discuss the challenges and opportunities of PFAS analysis. We hear a lot about PFAS contamination caused by firefighting foams, also known as AFFF, or from point sources such as the fluoropolymer industry. But there are additional sources of PFAS that deserve our attention. That is, their use in paper coatings. My next guest investigated this potentially underappreciated source of PFAS to the environment and took some very creative approaches to track their emission. Now, Håkon Langberg is a consultant at the Norwegian Geotechnical Institute and a PhD student at the Norwegian University of Science and Technology. He's here today to discuss these findings from his recent paper on environmental pollution. Håkon, welcome to the show.
Thank you. Glad to be here.
I should say before we begin, I put a link to this paper and associated papers in the podcast posting for those that really want to dive deep into the study. But your study showed that this lake environment at this lake in Norway was quite contaminated with PFAS. And I believe primarily you looked at sediments and biota. But before we dive into the study's main finding, can you set the scene for us? Where is this lake located, actually, and what is the name? And what's kind of the general environment like there?
Yeah, the lake is called Tyrifjorden in Norwegian, so we called it Lake Tyrifjorden in the papers. Okay. It's located a bit north of Oslo, so about 1 hour drive from Oslo, so in the southern part of Norway.
Would you say overall it's a fairly pristine lake, or is there a lot of...
Yeah, the interesting thing is that the reason that this pollution was detected in the first place was that this lake was included in a monitoring program as a reference lake.
Oh.
But then they found that this lake was as contaminated as a lake located next to an airport. And nobody knew why. So they looked at the PFOS concentrations in fish, and it was comparable in this lake to that lake in proximity to the airport. For a Norwegian lake, it's quite contaminated. It's, as I said, the same levels as next to a major airport. Wow. But compared to the very heavily contaminated lakes around in Europe, it's not that contaminated.
So one of the things I found most intriguing about your paper was that you looked at the sediment depth profiles. And environmental chemists can use these depth profiles to really investigate temporal trends of chemicals like PFAS through time. And that is, you looked at the various slices and essentially recreate these snapshots back in the past. What did your time trends show in your sediments?
Yeah, that was very interesting because we saw that in the sediments dated to have settled around 1960, we saw very high levels of precursors to PFOS, which have been produced by the kind of old PFOS production methods called electrochemical fluorination. But then around the 1990 we saw a shift into telomer-based compounds, so fluorotelomer sulfonates, and especially the long chain, so fluorotelomer sulfonates with the chain length between 8 and 14 fluorinated carbons.
Yeah.
Which is a bit unusual. I haven't seen those compounds reported in many studies before.
No. Yeah, but really interesting that you're able to track, these differences in the source of the chemicals, the industrial source. You mentioned from the older electrochemical process to the fluorotelomer process.
Yeah.
What does it look like these days?
The thing is that this factory, it shut down in 2013.
Yeah,
So
if we could, I want to explore the types of chemicals that you did detect in those sediments. So with the electrochemical sources, that pulse, what sorts of chemicals did you see there?
yeah, we see some PFOS, and then we see uh, significantly higher levels of PFOS precursors, such as yeah, call call them etfosa, and so
Mhm.
on. But we did find very high concentrations of like a parent compound to all of these called diester, which
Okay,
is basically, it can be transformed into two PFOS
okay,
substances in the environment.
okay.
And we
So
saw more than 3,000 microgram per kilos
wow,
of that in the highest contaminated sediment samples,
yeah,
which is
interesting.
very
Yeah,
high.
yeah, very high as a potential precursor to PFAS. And so Håkon, I wanted to dive in a little bit too and sort of circle back. You mentioned the really high concentration of that SAMPAP diester. I don't think many viewers would be familiar with its structure. How does it differ from something like PFAS, which ultimately it could degrade into?
Yeah, the thing with SAMPAP diester is that it contains kind of two PFOS molecules within its structure. And these are bind together by a phosphate group.
Okay, interesting. Okay. So, yeah, the phosphate group associated with paper manufacturing somehow,
Yes.
or paper coating manufacturing, right?
Yes.
Um, and then the fluorotelomere pulse that you saw later on, what sorts of compounds were associated with that?
Uh, they can in the environment be transformed into these carboxylic acids like PFOA and longer chained homologs. But we weren't able to really go into that, but that is something we want to investigate in the future. But I suspect these fluorotelomere sulfonates to be degradation products of another parent compound that we've called FTMAP. That is
Okay.
the acronym. And it is similar to the SAMPAP diester compound. It contains a phosphate group, and then it has kind of two uh, telomere sulfonate substances within its structure.
Yeah. Yeah, cool. So it sounds like the two groups of chemistry were similar in the fact that they had that phosphate head group,
Yeah,
but
I believe
the
so.
tail was different. Yeah. Okay.
Yeah, that is my understanding, but we haven't been able to really target these FT maps
Good. Okay.
at the moment.
Let's get into a little bit about your analytical methods. So you used a targeted approach, but you also used a non-targeted approach. Why did you do that?
The thing with PFAS, as you know, is that there are thousands of compounds that could be in the environment. So it's, I would say, almost impossible to target them all.
Mm.
So we had analytical standards for uh, about 40 compounds. And then we had some compounds that we could not target, but we suspected them to be in the environment, included some polyester.
Yeah.
So we did some screening for them based on their mass to charge ratio.
Okay.
And then we identified at least this some polyester compound, and were able to quantify it afterwards.
Okay. So would it be fair to say without using the non-target technique, you may not have found some of these PAP diesters?
Yes, that is
Yeah.
correct.
Cool. All right. So it really demonstrates the utility for using non-target approaches to understanding the full burden of PFAS.
Yes.
in the environment. Yeah. And then finally, too, you use something I think it was really interesting and really underutilized, and that was an extractable organic fluorine measurement. Can you just describe to us the benefit of using that?
Yeah, the really huge benefit with using the EOF method is that we can kind of quantify the unknown fraction of organic fluorine, and we're assuming that that is basically PFAS. So we saw in our samples that this unknown fraction was very large until we identified the SAMPAP ester compound, and then that compound alone explained approximately 50% of the unknown fluorine.
Wow. Okay. So that's great. So through your combination of targeted and non-targeted analysis, you believe you're able to explain about 50% of the total organic fluorine in the environment. So much better than a lot of other papers, but still, still some work left out there for another study.
Absolutely.
Yeah. Now, also, we need to discuss why PFAS were used in paper manufacturing or paper coatings, right? I think, again, a lot of people here understand AFFF firefighting foam and nonstick coatings for cookware, but what's it doing associated with a paper factory?
Yeah, it's actually the same reason as why it's used for cookware. So it is to give the paper oil and fat and water repellency. So it's used for microwave popcorn bags and fast food paper and so on.
Okay.
And that has been actually the focus of some studies, but only on the paper, while we are looking at the environmental emissions from the production of those products.
Thanks so much. Again, really cool study. First of all, demonstrating that there are other important sources of PFAS that we should be looking at. In this case, the paper manufacturing plant. But also, the use of the sediments to look at a temporal snapshot and looking at the changes in production through time. And then finally, using your non-conventional analytical techniques, right? The benefits of using that non-target to identify compounds that aren't on most people's monitoring lists. And then also using that extractable organic fluorine to see how much of the total fluorine and potentially total PFAS burden we're able to quantify. So really interesting work. Look forward to some updates down the road.
Yeah, thank you.
I wanna be with you like a forever chemical.